Good morning, students. Welcome to the Organic Chemistry 2 lab. Today we are going to perform the synthesis of Stilbene. As always, you can go here to the reference to go more in deep into the experiment's details or as well as the mechanism, or also you can use it to study for the quizzes. So let's go ahead. So, first of all, let's review the properties of Stilbene. This is the opaque name of a stirpene. It can be named either 1,2-diphenylethane or 1,2-diphenylethylene. You have two conformations of stilbene, the E-stilbene or trans stilbene and the C-stilbene or cis stilbene. Both have the same molecular weight, the same molecular formula, and the appearance of the trans stilbene is white solid at 23 degrees, and the cis stilbene is colorless liquid at 23 degrees. The melting point also are very different. The trans stilbene has a melting point of 122 degrees Celsius, while the melting point of the cis stilbene is around 5 degrees Celsius. Both are non-miscible of water. So, in general terms, in order to synthesize a stilbene from benzaldehyde, we are going to need, of course, benzaldehyde and benzyl triphenylphosphonium chloride. So, how the synthesis is going to proceed is you are going to have in the mixture two phases or two layers. One of the aqueous layers, which is going to be basic one with sodium hydroxide, and an organic layer, which is going to be DCM. As a result, you're going to get the mixture of both He and Z stilbene. And also you are going to get byproducts of the reaction, which is going to be this byproduct of this that you can see over here, sodium chloride and water. How to make benzyl diphenylphosphonium chloride. So we are going to start from diphenylphosphine and with benzyl chloride. We can also use benzyl bromide. So in this case, as you can see the mechanism, the electrons that occupy the non-bonding orbitals of the phosphor in the trisphonylphosphine are going to attack the electrophilic carbon in the benzyl chloride that you can see over here, and at the same time the pair of electrons of this bond are going to migrate to the electronic cloud of the chloride, and as a result you're going to get a salt in which the cation is going to be benzyl triphenylphosphorium and the chloride is going to be the contra ion, or I mean the anion. So, but in this case, if you will perform the experiment, the benzyl triphenylphosphonium chloride is going to be provided to you, so you don't need to synthesize. So, if you go to the left here, you can see this a very important scientist, which is George Whiting. This was a German who won the Nobel Prize in 1979, and he developed the one-spot synthesis of stilbene, which is named the synthesis of Whiting reagent. So the synthesis in this case is the first experiment is in sodium hydroxide, in aqueous sodium hydroxide, and we are going to get the Whiting reagent plus water plus sodium chloride. The Whiting reagent it has an equilibrium, tautometric equilibrium within these two conformations, in which this conformation, the one that you have more localized, the positive and the negative charge in both the the phosphorus and the carbon. In this case, you're going to be able to see the mechanism. These electrons that are over the carbon over here are going to attack the electrophilic carbon of the carboxylic group in the benzaldehyde, and this is going to be an intermediate or a transition species that is not going to be as stable, of course. It immediately is going to be reorganized, the charge, to be a more stable compound, right? This compound, that which name is oxaphosphonate, is going to reorganize and get the trisphenyl oxide as well as the mixture of E and Z stilbene, which is going to be the third and last step of the synthesis. So in this experiment, we will perform step 1 to 3 in the separatory funnel, right? So the steps are as follow. As you can see here, all these 14 steps that we have. First step, you will need to take 125 milliliters separatory funnels plus a right size of glass stopper. Then by using the funnel, you need to add 3.9 grams of benzyl triphenylphosphonium chloride. You need to wash and remain any remaining powder with 15 milliliters of DCM. Then you have to add 1.1 to 1.2 milliliters of benzaldehyde. Add 40 milliliters of 50% aqueous sodium hydroxide solution and shake the separatory funnel for 35 to 40 minutes. As you can see here, occasionally you need to bend the pressure by taking off the stopper. This is very important when you perform any separation or any synthesis in a separatory funnel, because eventually the gas are going to increase the pressure inside the funnel, and you need to release that pressure by taking out the stopper of the funnel. Step number 7 is going to be to add 20 milliliters of DCN and then shake gently. Still down the separatory funnel to separate the layers. After the reaction, then you have to drain the lower aqueous sodium hydroxide layer in a beaker. So in this case, you're going to get the aqueous solution, since it's a saturated solution. Aqueous solution down is going to be more dense than the DCM in this case, and then you need to dry the lower aqueous phase to a beaker and keep it there. Then you have to add 10 milliliters tap water into the separatory funnel and shake gently. Collect the lower DCM layer in an LR measure. Add magnesium sulfate, which is going to be around 2 spatulas, into a DLR flask to dry the solution of DCM. Then do gravity filtration to remove the magnesium sulfate. Collect this filtrate in a beaker. And finally, label and store your solution in a proper cabinet for the next week lab. You already have your product. So here, as we saw before in the previous experiment, is just a reminder of how to put or to set up the gravity filtration filter paper, right? You need to put it this way, the filter paper, in a funnel and in a LL measure to filtrate the solution. So this is a very important slide. As you can see here, it says few things to pay attention. It means that these are the keys to perform the experiment with the highest quality, right? First, as I mentioned, shaking the separatory funnel with volatile solvents like DCM will create a lot of pressure inside your separatory funnel. It means that you need to release that pressure by removing the glass stopper. This is very important. I will say that around each 2 minutes you must remove the stopper and in order to release the gas. Also, 50% sodium hydroxide, and this is very important, is extremely corrosive. It means that you always must wear safety goggles and gloves, but in this case, it's much more important to use your protective mediums properly, right? In order to protect yourself. Then also, if 50 milliliters sodium hydroxide solution spilled into your skin, you need to wash immediately, thoroughly, it's very important, until for around 15 minutes under running tap water. DCM is a very complicated solvent. It's very volatile and toxic. You always want to keep your reaction flask inside your hood. And this is very important. Most of the time in organic chemistry, you will need to work inside the hood in order to protect yourself from the toxic vapors, mostly coming from the solvents, right? That are in most of the cases are volatile and the gases are toxic. So in this case, you need to pay close attention to when working with the solvent, because in this case it's a very volatile solvent. The waste disposal of all the wastes, right? The magnesium sulfate is going to the solid waste. The aqueous 50% sodium hydroxide solution that comes out from the separatory funnel is going to the aqueous waste. The halogenated waste is going to be used to discard any additional dirty DCM. And of course, you have to do the cleaning. Clean the glassware with soap, water, and if needed, acetone. Clean your hood, of course, and clean the balance area, of course. And as a TA, I must ask you to do these duties because this is your responsibility to work first, work as safe as possible to dispose all the waste into the proper waste container, and also before leaving and after you finish your experiment to clean your glasswares and your work area. I think this is all for today's experiment. I hope that you understood all the steps of the reaction, and as always I tell you, if you have any doubt or you want to clarify something more in depth, you can contact me using my email from Monday to Friday. I will be more than happy to help you if you need any help. So I see you next week. I hope you have a great week. Bye bye.